In this lesson, you will learn about the Intrusion Prevention System, IPS. After completing this section, you should be able to achieve the objective shown on this slide. By demonstrating competence in IPS, you will be able to deploy, tune, and troubleshoot IPS in an enterprise network. In this section, you will learn how to deploy and tune IPS inspection in an enterprise network. IPS uses signature databases to detect known attacks. You can also use IPS signatures to detect network errors and anomalies. Like the antivirus signature databases, the IPS signature databases are also updated through FortiGuard. There is no single correct way to deploy an IPS solution. It depends greatly on the network and application requirements. However, in most cases, you will follow the steps shown on this slide. There are usually 3 stages in the deployment of an IPS solution. Analysis. The administrator defines what to protect and where. Evaluation. After an initial IPS configuration, the administrator makes further adjustments based on the IPS logs. During this stage, you configure the IPS only to monitor traffic, not block it. Maintenance. After the IPS configuration is working correctly, the administrator sets IPS to protect. The administrator must continue to monitor the logs and make further adjustments if any false positives or negatives occur. You will learn more about each stage in this lesson. During the analysis stage, you must identify what services to protect, the threats to those services, where to enable IPS inspection. Set realistic expectations. Focus on protecting the services that need protection. Start with the most critical services and classify the threats into groups. During the evaluation stage, enable just one group of signatures at a time, starting with the more critical ones. Wait and analyze the logs. If the logs indicate any problems, fine-tune the IPS configuration. After you feel comfortable with one signature group, enable IPS protection for the next group. This process can take from 1 to 2 weeks. To minimize the number of false positives, make the list of signatures that you set to block small and precise. The list should include the attacks that are most dangerous to critical services. After you deploy the IPS solution, you must continue to monitor IPS events. When you check IPS events, start with the events that have been generated the most or have high priority. For each event type, analyze the IP addresses, services, and type of attack. The analysis should help you identify whether the event is a genuine attack or a false positive. Eliminate as many false positives as possible. For each false positive, try to fix the problem by making changes in either the source or destination of the traffic first. You can also use IPS exemptions. In this section, you will learn about advanced IPS configuration settings. The global IPS configuration settings affect the IPS engine operations for the whole FortiGate device. Most of the time, you don't need to modify these values because the default ones work well in most scenarios. However, under certain circumstances, changes to these settings may be beneficial. The Intelligent Mode command controls the adaptive scanning behavior of the IPS. When you enable adaptive scanning, IPS determines when it is secure enough to stop scanning the traffic in each session. When disabled, IPS scans every byte in every session. In this section, you will learn how to create custom signatures. There are 2 categories of Fortinet IPS signatures. Predefined signatures are developed by FortiGuard analysts, which are distributed as a part of regular FortiGuard update packages. Custom signatures are created by users for specialized applications. A custom signature is made up of a type header and a series of option and value pairs. All custom signatures require a header of FSBID. An option starts with --, followed by the option name, and sometimes a value. Some options don't require a value. You must enclose the string of option and value pairs in parentheses. Also, keywords are case insensitive and values are case sensitive. You can include multiple options in the rule by separating them with a semicolon. The maximum length is 1024 bytes for custom signatures and 4096 bytes for predefined signatures. Now you'll learn about supported option types. The options are divided into 4 categories based on their purpose. When creating a custom signature, you must define required options, which are name, service, and flow. The signature name must be unique for each custom signature. The maximum length of a signature name is 64 characters. The service option specifies the session type, such as HTTP, FTP. You can only use the service keyword once in a signature. If a signature has neither a service keyword nor a port keyword, it will be added to all service trees, including the unknown service tree. Similar to service option, the flow option can appear only once in the signature as it defines flow direction of the detection packet. Use protocol-related options to match protocol headers. Use payload-related options to match portions of the packet payload. Use special options for various purposes for more granular filtering. In this example, specifying application category will result in the signature appearing under application control instead of IPS configuration. If you are planning to create a custom signature, gather as many samples of the traffic as possible. Good samples help you to identify patterns. For example, source ports, destination ports, specific string patterns in the packet payload, and so on. Try to match payload patterns in addition to protocol patterns, because payload patterns tend to be unique to the specific traffic that you want to match. In this way, you might be able to reduce the number of false positives for the custom signature. In this section, you will learn about hardware acceleration options for IPS inspection. The CP is a coprocessor for the CPU. It accelerates many common resource-intensive, security-related processes. Since the very first FortiGate model, Fortinet has included a CP in the design. The CP works at the system level. CP8 and CP9 provide a fast path for traffic inspected by IPS, including sessions with flow-based inspection. CP processors also accelerate intensive proxy-based tasks, encryption and decryption, SSL, antivirus. Network processors, NPs, provide the following features: pre-IPS anomaly filtering and logging, packet offloading, link aggregation, IPsec encryption and decryption. SOC combines a general-purpose CPU, NPs, and CPs into a single chip. It accelerates IPS-inspected traffic. SOC is found in desktop or small office models. In this section, you will learn about IPS troubleshooting. There are 2 important types of daemons that handle IPS-related tasks. IPS Engine is the main type of daemon that handles all inspection and detection tasks. IPS Helper handles actions whose results can be shared by different IPS Engine daemons. In some FortiGate models, it is normal to see multiple instances of the IPS Engine daemon running. IPS goes into fail-open mode when there is not enough available memory in the IPS socket buffer for new packets. The IPS also goes into fail-open mode when the FortiGate is in conserve mode. What happens during that state depends on the IPS configuration. If the fail-open setting is enabled, some new packets, depending on the system load, might pass through without being inspected. If it is disabled, new packets might be dropped. The IPS fail-open event generates a log in the crash log. The log indicates if new packets are dropped or passed through. IPS fail open entry and exit events also generate event logs. Frequent IPS fail open events usually indicate that the IPS is not able to keep up with the traffic demands, so try to identify patterns. Has the traffic volume increased recently? Have throughput demands increased? Tune and optimize your IPS configuration. Create IPS profiles specific for the type of traffic being inspected, and disable IPS profiles on policies that don't need them. Short spikes in the CPU usage by IPS processes could be caused by firewall policy or profile changes. These spikes are usually normal. Spikes might happen when FortiGate has hundreds of policies and profiles, or many virtual domains. Continuous high CPU usage by the IPS engines is not normal, and you should investigate it. If there are high CPU use problems caused by the IPS, you can use the Diagnose Test Application IPS Monitor command with Option 5 to isolate where the problem might be. Option 5 enables IPS bypass mode. In this mode, the IPS is still running, but it is not inspecting traffic. If the CPU use decreases after that, it usually indicates that the volume of traffic being inspected is too high for that particular FortiGate model. If the CPU use remains high after enabling IPS bypass mode, it usually indicates a problem in the IPS engine that you must report to Fortinet support. If you enable IPS bypass mode, remember to disable it after you finish troubleshooting using Option 5. Another recommendation to keep in mind, if you need to restart the IPS, don't use the Diagnose sys-top kill command. Instead, use Option 99 as shown on this slide. This guarantees that all the IPS-related processes will restart properly. If the IPS is generating false positives, first determine which signature is generating them. You can use IP exemptions as a solution. Additionally, you can provide sniffer samples and the matching logs to the FortiGuard team for further investigation. False negatives are more difficult to discover and troubleshoot. Check the following. Is traffic hitting the correct policy or IPS profile? Use sniffer and debug flow if necessary. CPU and memory use is normal. IPS engines aren't crashing. IPS configuration is correct. Again, after you verify all of those factors, you can collect sniffer samples and, along with details of the application traffic, provide all the information to the Fortinet IPS team for investigation. This slide shows the objectives that you covered in this lesson.